Hello! In this presentation I would like to introduce you to a whole home power filter, which was designed by me approximately 17 years ago. This power filter serves two functions. One, it reduces dirty electricity, which is harmful to your health, and number two, it reduces the utility bill because it causes your appliances to draw less current. Whether you're in the UK or in Canada, you are not paying for voltage. You are paying for how much current you draw from the utility. The first thing that we must discover is what is dirty electricity. Some of the slides presented here were taken from a previous video that I've done on the topic years ago. I have now consolidated basically 3 videos into the one. On the one side here, on the left, we see clean electricity, which is a sine wave, and on the opposite side we see dirty electricity, which is depicted with all the spikes and things on it. These spikes, you'll notice, cause the voltage to be way above and way below the prescribed 120 or 240 volts, depending on where you live. This screen shows a voltage check that was done at a school. It was a high school, and channel 1 was connected to the 120 volt AC utility line supplied by the power receptacle. Channel 2 was connected to the same potential except through the Graham filter, which removed the 60 Hertz cycle. So what the red part is trying to depict is the amount of dirty electricity which was on the power line. In this case, it was measuring roughly 25 kilohertz, 25,000 hertz. A teacher who previously occupied the room died of a brain tumor, and the teacher in the adjoining room died of leukemia. Dirty electricity is nothing to write off. It has very serious health effects. Now, if we look at input A, right, which was connected to the 120 volt line, we find out that our voltage, the maximum is 171.28 volts positive, and the minimum, because it's reading below the line, is 173.72 volts negative. If we look at the sine wave and the red lines, we can see that the red lines are well above and well below the prescribed 120 volts. If we look at input B, it is actually overloaded and underloaded from what we had specified on the screen. Therefore, this dirty electricity is a serious issue. Do you suffer from anxiety, blood pressure issues, brain fog, burning sensation, depression, headaches, heart issues, or sleeplessness, and or vision problems? You may have one or more of the situations outlined on this list. Now, it should be noted that if you have sleeplessness, for one example, that can cause health issues because your body repairs itself while it is sleeping. If you can't sleep, you will get run down, malnutrition, and a number of other health issues. The problem is that fluorescent light bulbs and the tubes, as well as desktop computers and laptops, cordless phone systems, solar power systems, video game systems, Wi-Fi routers and modems, blenders and mixers, as well as some coffee pots, light dimmers, televisions, multi-speed fans, home entertainment systems, smart meters and appliances, as well as battery charging devices for cell phones, tablets, etc., as well as hair dryers, often use what is known as a switch mode power supply, which means they all contribute to dirty electricity. This is done because in the old days, when something was manufactured and a manufacturer wanted to change the voltage of the circuit, they would use what would be known as a power transformer, which is a fairly heavy, fairly expensive thing to manufacture. Therefore, it was cheaper, but not better, to produce what is known as a switch mode power supply, which contributes to the dirty electricity I've shown you on the previous screens. A smart meter is shown here on the one side, on the left-hand side, with the X under it, and an old analog meter was shown on the right side. This is particularly of interest because if you have a smart meter, and in the UK they're typically within the household, you are being exposed to not only the dirty electricity, but also the RF transmissions that come off that meter every few seconds. The old analog meter with the green check mark never had this problem. Analog meters did not transmit, and we did not have time of day billing. The reason the smart meter is a problem is because we do in fact have time of day billing, and every few seconds it's sending a signal to the power company, billing authority, which tells the billing authority how much electricity you're using between intervals. These intervals are very often only a few seconds, if that, apart. So you're being exposed to RF transmissions 24 hours a day, 7 days a week. The safety standards for RF exposure were measured over a 3-minute to a 6-minute period, depending on where you get your test information from. They did not account for 24 hours a day repeated exposure, basically consistent exposure. Therefore, all the RF tests that have been done do not accurately depict any health concerns or other issues that may arise from the prolonged exposure. The meters shown here are typical of ones in the UK and in Europe. The meters shown on this screen are typical of ones that have been deployed in North America, that being Canada or the US. The meter on the one side has a digital display and is common for Ontario Hydro or Hydro 1. The meter on the opposite side is an old analog kilowatt-hour meter, which again does not contribute to dirty electricity. It actually used a system as two coils, one opposing the other, and it moved a number of dials, which then gave us our kilowatt-hour reading. The meter that does not have the digital display is the meter that you want. Now, what many utility companies did is they stated that the meters expired. However, this is untrue. I've contacted Measurement Canada in Canada and a number of utilities in the States, and the meters in fact did not expire. The reason they were installed was to save the utility company from sending out a meter reader, and also to consistently report your electricity usage so they could implement time of day billing, and in some cases they actually act as a transmitter to report what appliances are being used within the dwelling or within the business. This becomes a surveillance tool. But the dirty electricity that it produces through the switch mode power supply is only one part of the problem. As I stated earlier, because the meter is transmitting every few seconds, you're being exposed to basically non-stop RF transmissions, which are not good for your health. If we look at the screen here, we see what is known as a spectrum analyzer. This is a very sophisticated device which most people would not have or know how to use. If we look at the waveform shown on the screen, you will notice it has a peak, but at the lower portion you will notice there's a bunch of squiggly lines. That could be depicted as dirty electricity. The utility company does not bother to verify that these meters do not contribute to dirty electricity. And since most people do not afford to have a spectrum analyzer because they're only going to need it once, they don't have such a device due to its cost and its complexity. So what's the homeowner to do? The homeowner basically has two choices. You can measure dirty electricity using a green wave filter shown on the left, or you can use a Graham-Stetzer filter shown on the right. These meters do not necessarily read the exact same number, even if they were plugged into the exact same supply. However, that's not the issue. What we're looking for here is to have the lowest number possible. We can see the Greenway filter reads 272 to 273 millivolts. The other unit, called the Graham-Stetzer unit, the white unit, is reading 212. There's no correlation between the two numbers. Graham-Stetzer states that any number over 50 on a Graham-Stetzer unit is classified as deadly. Okay, fair enough. So we want that 212 number to be as low as possible. The other thing that a person can do to reduce the amount of RF, or the amount of transmission which is coming off of a power line, is to install one of these cores. These are ferrite core assemblies which simply clamp over the power line. The problem being that you would need one of these ferrite cores over every line after it leaves the circuit breaker or the fuse, and you would need larger ones on the incoming power lines. This will reduce the amount of noise that can be transmitted and or picked up by the lines in your house. Remember that those power lines run through walls, ceilings, under floors, so they're all emitting some form of a EMF, electromotive force. And they may in fact be emitting some RF. The lines themselves can act as antennas and pick up stuff from 5G or other wireless networks. This is not going to remove a whole lot, but it is something. What we actually need is a power line filter or a power line conditioner, which is what my whole home power saver unit does. To make things simple, clean electricity looks like the sine wave shown on the left-hand side. Dirty electricity will have the sine wave, and then it will have other frequencies superimposed. And this is caused because of the switch mode power supply and the ability of the wiring within the building to actually pick up some RF from outside. It's not a perfect antenna, but it will pick up some. We want to reduce this dirty electricity. When we use the whole home power filter, I have compared it with no filter and with the Graham-Stetzer filter and then my filter, because I'm aiming to build the best product possible. Measurement without a Stetzer filter is 470 Graham-Stetzer units. The measurement with the Stetzer filter is 147, so it's better. However, with my whole home power filter, it's 30. The problem with the Graham-Stetzer filter, or the Greenway filter, is that you need a number of them, and because in North America we use what's called split phase, you would need some on both sides of the circuit. You may have to purchase 10 or 15 units to reduce the Graham-Stetzer number down to something lower. In my case, however, the whole home power filter unit does both sides at the same time. Therefore, you buy one unit and you're done. My unit also comes with a plug. And that means if you move, you can unplug the unit and take it with you. Or if you have two properties, you can unplug it if you're not at property number 1 and bring it to property number 2. That will solve the whole problem. To show that my unit saves on electricity, I'm showing an amp meter here, which shows current draw on an electric motor. In this case, it's slightly above 7 amps. This is without a power saver. If we now look at the amp meter, it's reading 2 amps. Therefore, the same electric motor is now running. However, it's only drawing 2 amps from the utility. Again, I repeat that you're paying for current, not voltage. So I ask a question. Would you rather pay for 7 amps to run that motor, or would you rather pay for 2? Clearly, if you're paying for 2, you will have less of an electricity bill, or if you want to look at it a different way, the utility bill will be lower. Is it going to cut your electricity bill or your utility in half, as shown here? No, because it has certain effects based on the circuit, but it will reduce your electrical consumption, and it will clean up your dirty electricity, which is the intent of the device itself. Here I'm using a digital meter to depict the same thing. In this case, we are drawing 6.18 amps from the utility, and it is running an electric motor. You will see a circuit or a switch on the right hand side, which is now in the down position, meaning the power saver is not flipped on. When that switch is in the upper position, then the power saver unit is turned on. Here we see the electric motor is still running. However, we're now only drawing 3.23 amps. So the current draw is roughly half, which is similar to what we saw before with the analog meter. I presented it both ways because some people may not trust an analog meter and other people may not trust a digital meter. Well, either way, both meters are reading a reduction in current draw, and that's what we're aiming for. So the unit's not only cleaning up the dirty electricity, it's also capturing it and feeding it into the load in such a way that the load can make use of it so that you're not paying for something that you're not using. And it's reducing it, which also reduces the harmful effects from the dirty electricity itself. So it's actually performing 2 to 3 functions. Here again we see the power saver unit flipped off, and again it's now drawing 6.12 amps. So that proves that the unit works. What I need from you, the viewer, if you're interested in this power saver / filter, please let me know by the email below, as well as your location and how many you would like. It is suggested, if you have you and multiple friends that want one of these units, perhaps one of you orders a number of units and you incur one shipping charge. And then when it gets to your property, your place, you can distribute those filters to your friends. This way you pay one shipping charge. The unit I've shown here is made for US and Canada, and they're provided with a plug and a receptacle which is wired to your main panel. The units that are made for the UK already have a plug on it, and you simply plug it in the wall to an existing outlet. You don't have to wire something new. The unit cost is $300 Canadian plus freight, or if you're in the UK, it works out to 162.33 pounds. If you're interested, please email me at the address below with your location and how many units you would like. I will then give you a shipping quote. I do not make a markup on shipping. If you agree, I will then send you an invoice. Once paid, I will make your unit and ship it out to you. Thank you. I hope you found this information useful, and it is designed to not only explain what dirty electricity is, but also introduce you to a unit which not only reduces the dirty electricity, but also reduces the overall utility bill from your power company or utility provider, billing authority. Thank you. Have a good day.